Okay, final question. Hooray! Okay, this one is a bit more involved. A bit of dimensional analysis is required. And I'm going to need you to know the expression for kinetic energy. I say need to know, I'm going to give it to you, and also in an exam situation, we'll give you that too. Okay, so let's have a go. Let's read the question. Let's go back. The question says, a cheetah starting at rest can accelerate up to a speed of 120 kilometers per hour. Oh my God. Given that a cheetah can weigh 70 kilograms, that's a little less than me. Okay. Actually, that's a little less than me 5 years ago. I probably weigh much more than 70 now, right? Calculate the kinetic energy needed to reach this speed. Okay, so it's going from a standing start, this cheetah, and off it goes. And then when it reaches its constant speed, so it's going to accelerate like crazy and then reach that constant speed. I want to know how much energy it takes that cheetah to go from stop to full speed. Okay, so and I've given you the top speed in kilometers per hour, which is a very sensible unit. If you're European, maybe, and obviously if you're in the States or here, you're going to use miles per hour. But kilometers an hour is a pretty sensible unit, to be honest, for speed. And mass is also in kilograms. Now, they are not necessarily SI units at the moment, so we'll worry about that in a second. Right, let's go and do this. So let me just rewrite that information here. So max speed, with me, max speed equals 120 kilometers per hour, and mass equals 70 kilograms. Okay, now the energy of any object traveling at a constant speed is given by this equation. Okay, now again, I'm not going to expect you to remember this. E equals a half mass times velocity squared. Okay. Let's do a bit of a dimensional analysis of this. Okay, what units are the SI units for mass? Okay, well, we know that they're kilograms. Okay, that's lucky because we're working in kilograms here. What about speed? Okay, so the units of velocity are meters per second squared. Okay, so the units are, sorry, that's acceleration, meters per second. Okay, or meters per second. Okay, so the units of energy, of kinetic energy, the units of energy is joules, right? Okay, always joules. Joules, SI unit. Get that in your head, right? Okay. But in this instance, I can express them as kilogram, and then remember velocity is squared, so it's going to be meter per second squared is equal to, let's say a joule is equal to kilogram meters squared per second squared. Okay, so just looking at these units, I've got kilogram, which is my SI unit for mass. I've got a meter, which is an SI unit for length or distance, and I've got a second, which is the SI unit for time. For me to be able to calculate the kinetic energy of my cheetah, you can calculate the kinetic energies of your tutors if you like. I need to convert this into a more appropriate unit. Actually, I want to convert it into, instead of kilometers per hour, I want to get it into meters per second first. Okay. So basically, that was a really waffly way of saying, before I make this calculation, I'm going to convert my speed to meters per second instead of kilometers per hour. Okay, so let's do that in two ways. So let's go back and let's rewrite that. Max speed equals 120 kilometers per hour. Okay, now we'll worry about the hour in a sec. Let's convert the kilometers first. Okay, I want to get a nice SI unit, which is going to be meters to meters. How many meters are in a kilometer? 1,000. Okay, so 120 kilometers per hour is equal to 120 times 1,000 meters per hour, which is equal to 120,123 meters per hour. Okay, halfway there. I also want to convert hours into seconds. Okay, how do I do that? Well, remember it's over hours as well. So I'm probably going to need to divide instead of multiply here. Let's just figure out how many hours, how many seconds are in a minute, right? 1 hour is equal to, okay, how many seconds? Well, how many minutes are in an hour? 60. How many seconds are in a minute? 60. It's equal to 3,600 seconds. Or I'm just going to keep using seconds, okay? And you can sit there and count them out if you want, but there are 3,600 seconds in an hour. So in 1 over hour, there is 1 over 3,600 seconds, okay? Or 1 over 3,600 s to the minus 1, okay? So this time I'm doing this one. So this time, 120, 1, 2, 3 meters per hour is equal to 1, 2, 0, 1, 2, 3, and this time it's going to be divided by 3, 6, 0, 0. That's a 0 there. Okay, get rid of a few zeros. 1, 2, 0, 0 divided by 36. If you do that on a calculator, that's going to give you 33.3 meters per second. Okay, right. Let's just figure out if I've written that to the correct number of significant figures. I actually haven't. The correct number of significant figures here is 1, 2, 3, 4. 1, 2, 3. I'm going to say 3. Okay. So yeah, that's fine by me. 3 sig fig. Yep. So that's the max speed written in terms of. Have I done that right? Yeah, written in terms of meters per second instead of kilometers per hour. Okay. That's only half the job because I need to use this equation here now. Whoop. That's B, remember. Okay. And to do that, that's the energy in joules. So I'm going to do a half. The mass was 70 kilograms. Now, kilograms is an SI unit, so I don't have to convert it. And my speed was 33.3 squared. Okay. Do that on a calculator, and you are going to get 38900 joules. Again, to 3 sig fig. Now, that's great. You've answered the question. A more appropriate unit to use, or a more appropriate prefix, would be, let's have a think, 38.9 kilojoules. Okay, and to do that, I just divided that answer by 1,000 because there are 1,000 joules in a kilojoule. Okay, done. Workshop 1 completed. Any questions? Get in touch. Use Teams, please. Cheerio.